You have to explain it.
Yeah. Gerhard. Hold these. These are blanks. So.
Okay, yes.
Mentioned to people that they have to have the speaker talk with them in the morning.
Oh, yeah. Yeah, so we can start it smartly?
Yeah.
Good point. Okay.
Just that have to either do it tonight or
Good idea. Okay, are you ready? Yeah. Okay, first a little housekeeping. Basically, just recall that we need to get these forms in. These are the speaker release and consent forms. If you have not, Gerhard has them, and if we need more, we'll get them printed. But we do need to get these done. Again, we're going to be videotaping various sessions and things here during the exercise, and even if you're not a speaker, we probably will need to get that. So it would be really good for everyone who is at this conference to fill out a form. And again, they're in that little bag that you got, and if you need one.
I think also some at the reception at the registration desk.
No, I don't think so. No, I don't. They're not at the registration desk. Gerhard is the keeper.
Good. So I have some more.
Okay. All right. Any questions about that? Okay, if not, then what I want to do is go ahead and give you a little bit about how this exercise is going to work. And so let me just tell you first that this is not a real threat. So for people on the web watching this live, this is not a real threat. One of the concerns we have, of course, is somebody will think it is, and we don't want that to happen. So this is not a real threat. And the goal is to have basically all of you serve as experts, most of you serve as experts, who are going to advise leadership as to what should happen given the information that Paul and others are going to present you about the nature of this threat. As you know, this threat is now posted on the web. The probability of impact is 1%. It could be a fairly large object, and so that's where we're starting. And then Paul is going to give you a lot of detailed information on how that all works. But again, when you go into these groups, and I'll describe what those groups are in a second, we want you to discuss among yourselves, representing the point of view of each of those groups, what you think should be carried forth through the leadership as a recommendation. Then we're going to challenge the leadership, who are going to be representing, shall I say the word, politicians. And politicians are the unknown in this whole equation because, as you know, technically we could actually do something about this, but we need funding and authorization. And those guys are the ones who are going to basically take your information and decide and weigh these other concerns, the other issues that we can't control, and decide what to do. Okay, so what we're going to do is we're going to divide all of you into 8 parts, not each of you individually in 8 parts, of course. And so I'll describe what those 8 groups are, and at the end of Paul and Mark's presentation, you'll get a chance to choose the group you want to be in. And then we're going to send you off and let each group discuss. So the first one is threat discovery and characterization, and basically what that group is going to be doing is talking about what's known about the physical characteristics of the threat and its orbit. For example, again, one of the first things leadership would want to know is, what is this thing? What's the nature of this threat? Is it real? And so forth. The second will be impact effects. So if this thing actually hits, why do I care? Somebody will say, it's not a big deal. We'll just take the hit. And I've heard that. So Mark will try to tell you what the nature of that would be. Deflection and disruption. So how would one actually go about deflecting an object like this? And we'll have a group that will focus on that. Campaign design will be one where we'll actually talk about the nature of the campaign to actually get something to an object. And that campaign could be an observation mission if the leadership decides they want to do that, or it could be a deflection mission. The decision to act, and this is a tough one. We want that group to say, well, is 1% high enough Should we actually do something or start some planning or start spending money, given that the probability is 1% and that 99% of the time it is going to miss the planet? What would you do if you were sitting in Congress? Communication. We'll also want to find out what information should be provided to the public. We'll have a group that discusses that. And if you're a member of the public and you don't know anything, for example, my wife is here. I didn't say you didn't know anything. but she's served on that group now for the past 2 conferences and absolutely loved it. So if you want to get involved and you want to look at it from a different perspective, that's a great place for you. Disaster planning and management, again, from one of the things that we've learned from briefing FEMA and others on this type of thing is when do disaster managers get involved and what should they be doing? And you'll get a chance to think about that. And then the last group is going to be the leadership group, and we'll have a few people on that one well, and their objective is to think like a politician, more or less, and to think about a national leader who has resources and other things that have to be expended and other priorities than maybe dealing with an asteroid. So, and you guys need to be convincing in what to do. Okay. So we'll do that after this. Let's see, we're going to be limiting, and so what happens is you guys are going to go off in your groups, and I'll tell you where those will be after we hear these presentations, and discuss this. You'll come back, and you'll get maybe 5 minutes to present your thoughts to the leadership. The key points that you want to make, 3 to 5 points is kind of what we're thinking about. Those 5 points that you would present to the leadership about your point of view. And so you'll have maybe 5 minutes to do that, and we'll see how the time works out on that. So, and then also we do have an opportunity to record some of this stuff. I'll talk to the group leaders about that, but we have an online page that we've set up. It's a Google Doc page, I guess, where you can actually, where the leaders can actually input the recommendations, and we'll record those. That'll be very nice, and again, this becomes part of the permanent record. And also, as you know, we are inviting people who are not at the conference to provide inputs as well, and there's a way to do that. And these people, for example, I'm from California, so we want people when they wake up in the morning to be able to look at the video of this discussion live, look at the press releases, and make their own comments back. And those comments will come into you as leaders or as experts tomorrow for that discussion. And so if you want to look, if you're outside of this group and are watching online, that is pdc.iaaweb.org, pdc.iaaweb.org, and there are instructions there about how to participate. So we invite you to do that. Okay, so we want to give you some basic information now about what this threat is, and I'm happy to introduce Threat Master Paul Chodas. So.
Thank you. Before beginning, let me take this out. Before beginning, I want to thank my collaborators who put a lot of work in designing this. This is not a one-man job, although I can take the brunt of the effort, I think, on this. This is a different scenario than we had at the PDC in Frascati, because you get to choose what happens. So this is, I feel, the obligation to brief you very thoroughly so that you can make some decisions, well-informed decisions on what happens later in the week. But I don't control it this time, which is really scary for me. You all get to make, hopefully, wise decisions. I'd like to thank my collaborators, Mark Boslow, Brent Barbie is up there. Of course, Bill Ayler has been leading this from the beginning. The Ames group, Lorian Wheeler and Donovan Matthias have helped a lot. So I have gotten inputs from a lot of different people. The idea here is to make this realistic, and we're going to make it even a little more realistic than in Frascati. So and we're not going to do role-playing as before. It's not going to be quite the same. So I'm going to be taking the role of briefing you, and you will be advising governments on what to do on a very realistic threat. So it begins on today's date, May 15th. It's all set up to be realistic, but on each day of the week, we're going to advance the time schedule by a year or two or more. And I'm going to take a very aggressive stance here and advance it very quickly so that we can get to the interesting part towards the end. So on today's date, we have a newly discovered asteroid that poses a small threat of Earth impact. And that's typically how all of these scenario would start. So let's get into some details. Now I'm going to basically give a data dump here and inform you of what's behind the scenario. There's a press release online. In fact, there's a website online that gives a lot of the information in a style that we would have done to the press. But for you, I'm going to just give you the information. The asteroid was discovered on March the 6th by Pan-STARRS, and it is in a nearly 3-year resonance with the Earth. So it was actually hard to discover prior to this year. About a magnitude 21, that's typical. It's designated 2017 PDC, which is not a real designation. This is not a real object, so that's a clue. It's a potentially hazardous asteroid because of its orbit. It is tracked, as typically with asteroids, it's tracked nightly. Okay, so we get observations every day, and we revise the impact probability daily. I'm representing the International Asteroid Warning Network, Tim, so I will be speaking on behalf of the IWAN. This asteroid is predicted to pass very close, and the dangerous date is July 21st, 2027, 10 years from now. So the warning time, as it turns out, will be about 10 years, a little bit more. And the impact probability on that date is only 1% today, based on the observations. So it's not very high. So we would say, in our press release, that impact on that date is very unlikely. So we don't expect impact. But that's how all of these scenarios start, isn't it? We know very little about the size of the object, and that's typical. We would know only its intrinsic brightness, and we have to assume a reflectivity or albedo. And so we have the range of 100 to 300 meters, a little more than it says on the website, by the way. We don't really know that. That's one of the main uncertainties we have early on, in addition to the orbit. It's reached a rating of 4 on the Torino scale, and this is the URL where today's information is stored, and we will update this to day 1, 2, 3, 4, 5. Okay, so that's where you can go for more information. The Torino scale, there's a star there showing, I'll use the pointer, showing the location of this asteroid, 1% impact probability, and we know 100 to 300 meters in size. Okay, the orbit of the asteroid looks like this. This is on the website, so I won't dwell on it. It's an eccentric orbit, a little more eccentric than last time. The black orbit is the Earth's orbit. The blue orbit is the asteroid orbit. The period, 3.35 years, a little bit inclined. Here's the size information. The asteroid is discovered here, March the 6th. It makes a little more than 3 loops around the sun, while the Earth makes 10 loops. Okay? It's not like they're just coming straight together. So it's a matter of what happens at this point where the orbits cross. So this little red square, I will enlarge into this large red square. This now shows the uncertainty of the asteroid position at the time when the Earth crosses the asteroid orbit. So we know where the Earth will be on that date very accurately, but we don't know where the asteroid will be. It could be any one of these red dots. Large uncertainty region. Many millions of kilometers, in fact. There's the moon's orbit for scale. So red dots typically show our uncertainty of position knowledge, and it's true throughout this scenario. Again, this is where we would predict the asteroid is on the July 21st date, and this is using data as of today. What happens is we're going to continue to observe this asteroid, and the amount of data we put into our solutions will increase, and therefore our uncertainty will decrease. So basically, within this uncertainty region, we're going to start narrowing it down, and we don't know whether it's going to be over here, or if it's going to be near the Earth. We don't know which of the red dots is the real asteroid. So that's this point. The uncertainty region will shrink as we add observations. Okay? Now, this is a kind of a graphic to show you what, in a zoomed up way, what that uncertainty region looks like in a geocentric frame. So I'm going to keep the Earth fixed. We're going to watch what happens as the Earth sweeps through the asteroid orbit. Each of these time ticks here, you can just barely see, is 15 minutes. So watch this. Here we have here, to here, to here, to here. Each of those was a snapshot in time, okay? And it shows the Earth encountering the asteroid orbit. Again, we don't know which of these red dots is the real asteroid, so we can assign a probability to each dot, basically. But you can see how the uncertainty region will slice through the Earth, and that's going to produce what we call the risk corridor, which you heard about earlier. I'll back that up. We can see that one more time. Okay, so that's how an uncertainty region becomes a risk corridor, and that is the risk corridor on the Earth. It's where the asteroid's orbit cuts through the Earth. Again, we do not know which of the red dots is the real asteroid, but as we gain more information, it will narrow down, and one of the red dots will be the likely red dot, the likely impacting solution, if that's the case. Of course, the asteroid might miss the Earth. So this is the western part of the risk corridor, goes all the way to the Atlantic, and on the east, all the way to the Pacific. It's more than 180 degrees because of gravitational focusing. Okay? All right. Now, I need to give you some information so that you can make some good decisions here. And the first thing I want to talk about is the apparitions. When is this object observable? So along the bottom, I have apparitions 1, 2, 3, and 4. These are the white regions, okay? When the asteroid is observable from the Earth. The pink regions designate the times when the asteroid is not observable, either because it's too faint, and this is apparent magnitude along here. So these are bright up here, and these are really faint magnitudes. So anything that's below 27, in fact 26.8, is I'm calling unobservable from the Earth. Okay? So that explains part of these pink regions, but also the solar elongation, that is the distance, angular distance of the asteroid from the sun, has to be less than 45 degrees. Sorry, it has to be greater than 45 degrees for us to actually see the asteroid from the Earth. So if we apply these two filters, we can only see the asteroid in these white periods. Not very many, we can't see it very often at all, and that's really a limitation. By the way, it actually goes in front of the Earth. There's a little invisible period in May. I want to call your attention to this point right here, okay? The asteroid is about 27th magnitude for a very short time, just because of geometry. I'm highlighting it here. Along the right-hand side, I didn't call it out, are the category of telescope that could observe at these magnitudes. So 1 meter could see roughly 21st, 2 meter you can see 22nd, 23rd magnitude. A 4 meter telescope would be required to see 24th, 25th. You can argue perhaps with some of these numbers. An 8 meter telescope, 25 and 26 magnitude. And HST might be able to see things at 27th magnitude, at least in this scenario, okay? So you need different kinds of telescopes to see this object at different magnitudes. But this is the first point to consider. Should HST try to observe it at this point? Should we bother even? It's pretty far. So now I'm going to explain this idea of how we compute impact probability versus time. This is a very important thing because we're not going to act in this scenario until we know what the impact probability is. The politicians want to know how likely the impact is. So we can predict when the asteroid is observable. I just showed you that. And we can also then predict how the impact probability would evolve with time because we can anticipate what the observations would be. And then we weight them with the typical accuracy of the observations, and that informs what the impact probability is. If we assume the worst case, then we can get an impact probability profile that is the worst case, and it shows us, in the worst case, how high the impact probability could get versus time. It's not going to be 100% for a long time, because that uncertainty region is very large. So it's going to take time to knock down the orbital uncertainty. In fact, we can predict that the impact probability could reach no higher than 10% in July of this year, and no higher than 26% by the end of the first apparition. That's using the best telescopes we have on the Earth. So, is that high enough? Is 26% high enough to act on by the end of 2017? 2017 is pretty late. There might not be enough time to deflect an asteroid that could hit 10 years from now. So this is a problem to consider. I'm I'm saying that space agency officials are considering funding a special observing campaign, as I just explained, to observe at magnitude 27 using HST or perhaps a VLT. So, oh, I'm sorry, yes. Hubble Space Telescope is, of course, capable of seeing to very, very faint magnitudes. So the question is, should we use it? Or VLT it's also possible. I'm sorry, the question? Yes, it is visible for VLT. It is. I have checked that. And my last point here, I have to go quickly here because Bill is on my case. If those observations aren't made, then the impact probability will remain frozen at 26% until the second apparition, which is 2019, which may be too late to act. Okay. Yes. Or Keck. Yes. Fair enough. Okay. So so that's one topic, narrowing down the impact probability by getting more observations. Next topic is impact risk assessment. What happens if it will hit the Earth? Now, the Ames folks, and Lorian in particular, Lorian Wheeler, has put together some slides, which I will show repeatedly on various days of this conference with different impact probabilities. And you can go to the web to find out how they make their assumptions. Basically, they take the 1,000 Monte Carlo cases of the risk corridor, which is how many were in my risk corridor, and for each point, they then put a distribution on various parameters of the asteroid, the physical parameters, because we don't know the size of the asteroid. We don't know its albedo. We don't know its mass. So they do the Monte Carlos to get some results. You can go to the web to get these slides. I'm not going to explain them, but they generally, the Ames folks have 3 plots they show: the blast damage zone plots, the mean affected population plots. This is what decision makers would like to know, and damage level probabilities of histograms of various damage levels. So I'm going to show those now for today's data. Here is the risk corridor in which Lorian has put the various PSI ranges using the Monte Carlos of the full range of sizes for this object. It could be as large as 300 meters, so that probably dominates most of these damage plots. I'm sorry?
Pounds per square inch.
Pounds per square inch. Okay, so this is the shock wave of the air blast. All right, so you can see that it could affect a lot of area, land area, at 1 to 2 psi, and it can go easily up to 10 or more psi in the red areas along here. These slides are on the web, by the way, so you can look at them in closer. The second of the Ames plots is the mean affected population. Here we have color showing how many people are affected as a function of the various points along the risk corridor. If it hits in the ocean, not very many people, perhaps. Well, there's a tsunami model that they use as well. But there are some very populated areas in Japan, in China, in Europe. Not so much over in Kazakhstan. Okay? So this is an interesting plot. It shows where the dangerous places on the Earth are to hit. We certainly don't want it to hit in these red areas. If it hits in the blue area, the model says that not very many people are affected, and also over there.
Could you again say in the plot before what type of damage you can expect for one given PSI?
Oh, yes. Now, I don't know whether I'm going to get this right, but certainly there's a different percentage of the population is affected, and in fact, casualties are a function of the different lines on this plot. And I'm not going to get this right, Lorian, but a certain percentage of people are affected at this level, but if you get up to the red area, most of the population is killed at that area. I believe that. Did I get that right? More or less. Okay, so so 60% here. What was the percentage here of 30? And here? 10. So 10, 30, 60, and 100%.
4 PSI is normally taken as the 50th percentile.
Okay.
Half the people die.
All right, half the people die in the bottom 2 categories, yes.
And what's left in the Windows break?
50%.
windows break at the top level, I think. I can't answer all the questions now, or I will run out of time. So let me finish my briefing, and then I will go to the various groups after when you break out. So one other thing that the politicians and the decision makers will need to know is what is the likelihood that we will have a massive number of casualties versus the likelihood that we'll have no casualties, essentially. Now, we are at 1% impact probability today, and this is the histogram showing the affected population all the way up to 100 million. And the probability that that would be affected is like 10 to the minus 4. But then when you go to, so the probability is a little higher for 10 to the 5th people, for example. So this is averaged over the entire risk corridor. That's today at 1% impact probability. In July, if the thing is headed for the Earth, the histogram will change to a 10% impact probability and the 26% by the end of the year if it continues to head towards the Earth. So I'm not going to go through the details in this, but you would get different histograms. And this one is 100% impact probability.
I think it's summed, not averaged.
It is summed?
You said averaged over the...
Yes, it is summed over the risk corridor. Thank you for that correction. Okay, the time is running short. Let me say a few things on how to get more information. This is our CNEOS website. That is the URL. If you go to Planetary Defense, click there, go to Impact Scenarios. You can go to this scenario, PDC 17. If you go to the NEO deflection app, you can actually practice deflecting this asteroid yourself. Later on in this week, we'll talk more about that. And this is the scenario homepage. Each day, we will activate a different one of these pages. The day one page is now active, and so you can get the information for day one if you click there. Okay, there are still a few issues to discuss, and that is deflection. This is a screenshot of the deflection app, which now defaults to PDC 17 as the object. You can actually try deflecting it yourself, and if you go to our website, you can find instructions on how to use this. One thing it shows is the B-plane, which is the kind of the view of the asteroid from the asteroid to the Earth. It's the target plane, really, the dartboard. The green dot is where it's headed in the current model, but in fact, there's a risk corridor, as I showed, of possibilities. It could miss the Earth, it sweeps across the Earth, and it could miss on the other side. I've taken the liberty of actually putting a map on this. So this is a very strange mapping in which I've unraveled the Earth to show where all of the landforms are. And now I'm going to rotate it because I like to have north up. So here we have the view from the asteroid. If it hits the Earth, it would be somewhere along the risk corridor, which is now a straight line. And this is the zeta direction in our B-plane frame. So when I say zeta, there's plus zeta is this way, the minus zeta is that way. It's where you are on this line. The length of that line is 12,000 kilometers. So if we deflect the asteroid by, you would think, 6,000 kilometers, we have it solved, right? Not so simple. Kinetic impactors can deflect the asteroid much more easily in going to the left, which is negative in zeta. That's an easy thing to do because of orbital mechanics. They have a much harder time deflecting an asteroid in the plus zeta direction. So let's say, what are we going to do if the actual impact location is somewhere over here? This could be worst case here, or one of these, because it's hard to go in this direction. I'm sorry. Yeah, it's hard to go it's easy to go in this direction, but that's the long way off the Earth. The short direction in this case is just hitting it the other direction, but that's hard to do from a kinetic impactor. Oh, my time is getting nearly up. There's a couple issues on this. I need to inform everyone because you will be making some important decisions here. So I'm saying now, we don't know the size of the object. That's another major uncertainty. For an Atlas V launch, and I'm giving a deflection date here, for a density of the asteroid, which we also don't know, of 1.5 grams per cubic centimeter, and a beta momentum enhancement factor, which we also don't know, if we plug those numbers in and we have the size of the asteroid diameter of 250 meters, this is how far we can knock the asteroid with one mission on an Atlas V. That is not going to do it. That is the power for these conditions. That's how far. You'd have to have several of these to step over the Earth, if you're knocking in this direction, to get it off the Earth. So you need not just one kinetic impactor, but several. Now you might say, well, what if it's a small object? 120 meters, let's say. In theory, if you plug in the numbers, you could knock that asteroid this distance, 26,000 kilometers, with a single mission at 120 meters. However, we stand the danger of disrupting an asteroid if we violate a certain rule. If we want to avoid disrupting the asteroid, we need to keep the delta V less than 10% of the escape velocity of the asteroid. This is a general rule that, thanks to the Lawrence Livermore folks, if we want to feel safe about not disrupting the asteroid and causing chaos with pieces flying all over, we'd like to keep it together. So if we apply that rule, then suddenly the largest distance a single kinetic impactor can knock the asteroid is 0.55 centimeters per second. What that means is not much different than this. We again need to have multiple kinetic impactors to knock it off the Earth. Yes? I'm sorry? The solid body, yes. Yes. Yeah, that's correct. That's all we can do at this point. We don't know anything different. A rubble pile, we hope that gravity would continue to hold it together. I want to make one last point. Don't bear with me, Bill. These numbers are for the minus zeta deflection. If we want to go, if we're over here and we just want to knock it that way off the Earth, the length of the line is different. It's a different mission for a kinetic impactor to go in the other direction. It's different in the sense that it takes a larger orbit, because you need to have an orbit that is larger than that of the asteroid if you want to accelerate the asteroid to move it in that direction. To get a larger orbit is not only more energy, but it's going to take longer to get there. So a kinetic impactor which knocks it in this direction will take longer. And this is my last slide. Thanks to Brent Barbie who put this together. I appreciate it. It's in Brent Barbie's package, and he can discuss this. It's on our website. I will, don't stand up just yet. There is a number of possible missions that we could launch to this asteroid. And we need all to consider what we would do, which of these are appropriate, and which combinations perhaps are appropriate. Let me go through them. The blue ones up here are reconnaissance missions. Build a flyby reconnaissance option. It would launch at the red, arrive at the asteroid at the green. Or we could build there's two others showing here. We could launch here, arrive there, launch there, arrive there. So the question then is, when is it best to launch to find out as much we can about the physical size of the asteroid and its orbital information? Because once you get to the asteroid, you've nailed down its orbit really well, and you know its size. So then you know how many kinetic impactors you might need. So there's three options there. A rendezvous mission is very useful for staying and observing and getting the mass of the asteroid, or observing whatever kinetic impactors actually do to see how much they move it. We don't know beta, so we might need an observer to stay there to measure how much we move an asteroid. There's two options there. And these are the kinetic impactor options here. Here's number one, which is the one that goes in the plus zeta direction. It has to launch early. It's a long flight time to the asteroid. There's two others that would knock it the other direction. It's interesting that the best time to deflect an asteroid is near its perihelion. These are not quite shown in the right numbers, but so the kinetic impactor would arrive at near perihelion. That's the optimal time to deflect. So there are so many questions to consider in this, but we need to perhaps consider which of these make sense. I would suggest that, in my opinion, it's a very good idea to find out early, but if we can't launch too early, if the impact probability is too small, we're not going to launch. So all of these factors are interrelated, and we need to pick which of these, if any, you want to launch to the asteroid. It doesn't take, a single launch can't do it. You need multiple launches, a characterization mission to learn about the asteroid, its mass, its size, its position, and the kinetic impactors to actually deflect. Now, one option that's on the table in this conference is nuclear. And nuclear does not have an asymmetry in direction. We can knock it in either direction equally well, because you can detonate on either side of the asteroid. And I will leave it there. Bill, thank you. Okay. Oh, yes, Mark Boslow to talk about impact effects.
Thank you. Okay, so I think my presentation is here, and in keeping with the spirit of the scenario, we did everything at the last minute because that's the way you would really do it. And we just finished putting together this presentation. Now, in the scenario, the risk has increased, or the probability has increased by something like a factor of 4 or 5 just in the last few weeks with new observations, if I remember correctly. And so we've marshaled our resources. Yeah, it's sorry. There, it's the second one from the top. No. Here, I'll get it. This one. There we are. Oh, now we need to go full screen here. How do I go full screen? There you go. Oh, we are full screen. Okay, sorry. Okay, let's go back. Okay, so I'm here to represent the Sandia team, which is interested in physical effects of the impact and consequences for people and infrastructure. Now, there's some redundancy with Donovan and Lorian, although they've done it in a more general way, and what we did was we looked at some specific cases. And so we've got the risk corridor that Paul had just put up, and we've got specific points along that where we assume an impact could occur. Now, from the perspective of disaster preparation and management, disaster preparedness, people who are in the disaster management business are concerned about worst cases. So what are the worst possible things that could happen? So Paul gave a significant range in possible diameter. We're assuming worst case. And worst case for us was about 270 meters in diameter. That's coming in at about 17 kilometers per second. That amounts to about 1.2 gigatons, 1,200 megatons. And there are a number of cities along that corridor, Tokyo being one of them, just by coincidence. So we looked at the number of people within 100 kilometers from the center line, 100 kilometers being the range at which the shock wave is strong enough to injure people, blow out windows, and that sort of thing. And we did a very first cut approximation using the Purdue impact simulator, which is a very useful tool for that. It's not an accurate tool for if you know the details, the precise details of the size of the asteroid, the entry angle, and so forth, but just for getting a first cut, it's very good. And so you can think of that as sort of the risk radius along that corridor. And this is a list of the number of people that live within that strip. And you can see, just for comparison, what countries represent the most risk, and it's Japan, China, and South Korea. The big cities in those countries are all in there. Russia, and Kazakhstan, even though they have a lot of area that it crosses, there are no big cities, major cities underneath it. So we focus on some of those bigger cities. And here is Tokyo, and in fact, ground zero is right where we are in this case. And this map comes from the Purdue simulator. We kind of use the damage as proxy for risk to people. There's actually a crater that forms. The diameter, or the radius of the crater is 1.9 kilometers. That's about 3 times as the diameter of Meteor Crater, Arizona, for comparison. So in the red, virtually anybody in that red would be killed by the blast. Now, there's also a fireball, there's thermal radiation, there's all sorts of other effects, but that doesn't matter. The blast wave itself wouldn't be survivable in the red. The outer yellow ring, that is where all the windows would blow out. You would be able to survive that if you sheltered in place. So in terms of risk management or disaster management, there are things you can do. If you know this is coming, you can save a lot of lives if there is no deflection or if the deflection is a failure. But, you know, and there is only a 1% chance that this thing is going to hit the Earth. So there's a 99% chance that that's going to go to zero with future observations, but it could go up, and neglecting to make a decision could lead to the destruction of a major world city, and if that happens, that's on the hands of the decision makers. So Tokyo, and these are the types of things that our Sandia team put together, and Barbara is going to lead the group on disaster preparation and management, and she'll go into this in more detail. And let me go to some movies to sort of give you a visceral feel for what happens. Now, the scale was up there for a little while, but this is a blast wave. Okay, it's 200 kilometers in diameter and 200 kilometers high. So this is a ballistic plume going out into space. There's a buoyant fireball pushing material out into space. I can zoom out a little bit. So here's the asteroid coming in, hitting ground zero. There's an explosion, there's a shock wave. Now that shock wave is poking along at something like 300 meters per second. It takes about 3 seconds to cover a kilometer. It takes 5 minutes for this to get out to a radius of about 100 kilometers. In the meantime, there's this supersonic jet that shoots out the wake. You can see material going out into space, and then there's the buoyant fireball pushing material into space. And I'm going to zoom out one more notch here, and you can see this runs actual 300 seconds, and you can see how high material goes. It's getting up into where the ISS orbits. It gets up into where the Hubble Space Telescope orbits. So there, you know, it's not just infrastructure on the ground that is at risk. And you can see the plume coming back down and collapsing on top of the atmosphere. This is the effect on the ground. This is a map view of the effect on the surface. Now, this is the part of the risk corridor where the asteroid comes in the steepest. This is a 240 kilometer by 240 kilometer box. There is this is wind velocity, so this is the velocity of the blast wave. The yellow is broken windows, the blue is complete and utter destruction. And I do have a movie, and I'm going to finish up with that. If I can show it here, and if Bill will bear with me just for a little while, I think I can be faster about it. This is coming in, this is the center, roughly the center of the risk corridor, and it's coming in at about 47.5 degrees from the horizontal. Yeah, that's about the maximum possible entry angle, and so this is in northwestern China, the city of Karmay, and so this is the blast wave moving out. Now, what you're seeing at the surface in the central part is, oh, there's nothing on the screen. Sorry about that. I'm looking the wrong direction. Okay, let me rewind it. Okay, so this is the closest case to the city of Karmay, which is actually the wealthiest city in China. So you can see it right below the red dot, and this is actually higher than the highest wind speed, which is 200 meters per second, beyond any hurricane force wind, and it's also very hot. It exceeds 1,000 degrees, so you're right in a fireball. So it's not survivable. in that central area, it's completely not survivable, and you can see the shock wave sweeping across the surface. And so it's a little bit different than what you would get from the Purdue simulator, which is completely isotropic and shows this bullseye pattern. The actual pattern is not a bullseye. It has some bilateral symmetry that depends on the entry angle and the other details. So I'll run. I'm sorry, I couldn't hear that.
Atmospheric end angle, what is the atmospheric trajectory angle? What is the entry angle?
The entry angle is 47.5 degrees from horizontal. 47.5 degrees, yes.
Then you shouldn't have this symmetric picture. It will be like a butterfly.
It is, yeah. If you plot the maximum wind speed and you store that, it does give you a butterfly shape. And we'll show some of those later in the week.
Your Windows person. This one?
Exercise, yeah.
Okay.
Now how do we get it? This is the world's simplest chart here. But what I want to do is just kind of introduce the exercise groups that we're going to be using, and this is where you can sign up for these things. So let me flick to the next chart. This is these are the people more or less will be doing this, and so again we need people to do those. So what I'll do is introduce the facilitators for these. So the first one is Marco Micheli. Are you here? Okay, so those people who want to go with Marco, and Marco, let's see, your room is the large room that we had. We had two rooms up there where we had lunch. Yours is the large room, and so you'll be one of the groups in there. We'll probably have two others. So anybody would like to go with Marco and talk about the threat discovery and characterization? And Marco, if you'd like to maybe stand over here and get the move, that would be good. The second group would be impact effects, and Mark Boslow, who just gave you that very nice presentation of scary things. He'll be facilitating that one. He's also going to be in the large room, so you'll go to the same place as Marco. The third one is going to be deflection disruption. So these are the people who are actually interested in how you're going to move this thing, whether it's going to be a kinetic impactor or what that whole thing looks like. So the people who will be doing that is Megan Brooks-Ayal. Megan, are you around? Back here. She'll be leading that one. Okay, so that's good. Let's see. The fourth one is campaign design. This is how you designing the mission to actually do something. And so those people would go with Brent Barbie. Brent, where are you? Okay, back here with the pack. Number 5 is the decision to act. Is the information sufficient to make a decision at this time? And Gerhard is going to lead that one. Gerhard's over here. And Gerhard, you're in the smaller room. And Brent, you're also in that smaller room where we had lunch, right? And the last two will stay in here. Oh, excuse me. The small room will also have Victoria Friedensen in communications. So you people are dealing with that side of the problem. We'll go in there. And then the last two are in here. Disaster planning and management. Detlef will be running that one. Oh, I'm sorry. Barbara is going to be leading that one. Barbara Jenkins, there you go. And so she'll take that one. And then the last one is going to be me. And actually, I'm going to hand that off to somebody here soon. But we'll just come and join me in this room. So the rest of you take off. Oh, and by the way, we need to be back here at about 5:15. So we don't have a whole lot of time.
lunch boxes, there were two. That's the smaller ones.
Okay, decision makers down here, please. And the people that are doing the work with Barbara, you can go up towards the top someplace, I guess. That would be good.
How do we get the input from the external candidates?
It's already being distributed.
It's been distributed.
Yeah.
Ah, okay, so we go to the small.
Yes.
Yeah, it's for the.
Yes.
A relevant point to say is
Yes.
the next inject is 2 years from now.
Okay. More or less. Okay.
So any decisions that have to be made in the next 2 years need to be done today.
Okay. Feel this thing, by the way. That is one weird feeling. Feel like it's wet.
What is that? Oh, it's like a gel thing. Oh, wow. So we are to act like politicians.
So what we'll do is we're going to put some chairs up here. And I think we'll just align them like this more. Have speakers come here. And so we're going to do presentations from each of these groups is what they think ought to happen. And then you guys are going to decide what really should be done.
So do we get to grill them? Or did they, is there a back and forth?
Maybe some limited degree. We don't have a lot of time, so maybe not. And so, but we'll have to play it by ear. So again, and the way this one works is your decisions are very important. Things will happen or not happen, depending on what you decide. So it's really important from that perspective. But also, you're going to have to defend your decisions to people who put you where you are, which also might be another thing you have to do. And so I'm just asking you to think about some of the other factors that you've heard today, like if one of us are high enough. They'll tell us what we have.
Who do you consider decision makers to be? Are they leaders of countries or the United Nations or
Well, you can say
Elon Musk?
some could be people who are along the photograph corridor, other along this way.
Thinking like elected officials.
But the officials
Absolutely. But we need to have a sort of consistency.
Do we control resources?
Yes, you can. You know whether money gets spent at lunch here so far. And all this. So you know.
there are countries that are also the sorts of experts. I mean, there should be some experts from the space agency, let's say.
Well, that's true.
Experts for,
But they're not on this group.
but the decision maker have to make an organization for getting some advices from these people.
But we're
So it's a part of,
That's who these
but
people are.
it's part of our group. No?
No. You're not in that role.
So we have the questions.
That's right. Exactly. Exactly. They do irrational things, and that's the kind of thing that's going to be a challenge for us. Should a real literature. Because you can imagine this. You had to go 3 continents.
Yeah. sitting there and you just decide to go somewhere else.
Yeah, but at the moment, it's the observation which is not going to influence the interest of the others.
That's how we're doing for the
完全に LOC なんですね。
本当このヘッドタイプに参加して who has the best technology and use that. We ask the scientists in your whole community, do you have the best? Yeah, because that's what the kind of thing the president would give you the best. And they gave us some.
Excuse me. Is somebody running that camera?
Yeah.
And will they be using that during the exercise?
Yeah. You need the video broadcast.
No, I'm just wondering. I was going to put some people here, but that wouldn't be so good, I guess. I could put them back here. Or maybe something like that.
Not so good. Okay.
You see? So should I have those chairs put somewhere else? Or
Sorry?
I will have chairs?
Yeah. Now I prepare the chair.
Okay, that'd be good. But I want to be sure that we do not block his view. You see?
Okay.
So we could. What would you like?
You want to try to the broadcast?
Yes.
Okay.
When they come back.
Okay.
Yeah.
今からここに2列椅子並べて、なんかディスカッションみたいな感じで、そうするとここからのビデオの次が悪くなる。どうしたらいいでしょう。移動してもいいですかね。2メートルぐらい。ここまで。じゃあここにまずビデオカメラにあるのというか、here.
They can. And then we would put I'm going to have about 10 chairs.
10 chairs, yes.
Yeah. 10, yeah. Okay.
はい、了解です。やっぱ糸かなあかんなここに。ちょっと変えてもいいかもしれないですね。受付に逃げる。
Same page. It's really relative.
No, but I mean in our main choices. We can ask who's this and all that. We're just talking how there's, in the 8 categories, there's no group that represents 5 on the same page.
Actually, there is. It's the sort of the so he's going to. Yes, actually,
まあそれに合わせて椅子を。
and they will come back to
But that is going to be different than what really happened in the where there's a real life scenario. Representatives of instructions from the whole month what they can and can't do. They're not going to go there as scientists, they're going to go there as representatives of their government. And it'll be a very different decision making than much science talking about.
Thing that we can expect in terms of decisions. First one, in the coming years, we will make
ここ斜めに2列。こんな感じか。こんな感じって言ってました。よくわからないです。 議論する感じ、パネルディスカッション的な感じにしたいんじゃないでしょうか。
far away, the position can be different. For beginner to prepare to make decisions physically the one that can start with on and it corresponds to some kind of breakdown. And the second one, which is the first one, because money you can justify money, you can make
そうですね、あと10です。5、5。
one country living their life for the benefit of another country. So it's different. So I think
Do you really think it's as much of somebody saying, I'm sacrificing my life for the benefit of somebody else, except for the direction aspect of it, but you guys may know, well, you don't have that much choice in direction. But there is going to be something, I think, sort of with perhaps expenditure of money. Well, we're not going to be poor, I'm less willing to spend it off. If the bill rises to the $100 billion range. But if it's in the $1 billion range, truthfully, it's like a marginal that's chunky.
Timing chart, and it basically tells you what kind of options that you guys have to think about. You won't get another update for a while, so again, you're in 27
2個あるからこれで映り具合のレイアウト。
Next update, yeah, I think so. I think it's like then. Yeah, it's a couple of years out, 2019. And so again, the question is, and again, given the fact that it takes some time to design, build, launch it, do you guys want to have to do that now, or not? Do you feel that you're justified in doing that to your people? And if you don't, then you know this thing will move. It's going to move to the right, and so you've got various things to do. And so that's a key decision.
Yeah, just do we, when do we launch it?
Where we are right now, あれがいいですね。
You had said that nuclear was on the table for this, but it's not on the chart.
That's something that they should discuss.
That is a question of when.
And they will come back and tell you that they without asking anything about it, I would guess. But again, the idea here is you can find, you can say you want to go start planning for the kinetic impact, or you efficient or start getting your ducks in a row there. Just recognizing the
あ、こっちにこう使ってるんですね。あ、どうもっと引いた方がいいのかな。
At some point,
今だけ大丈夫です。
But you get exercise like that.
Or
次何時からだっけ5時
on the US.
frozen, it frees the radiation. So I think the norms, the confidence loading measures, something of the states will be using. They will talk about, okay, so if you do that, what does it mean for me now? If you do that, what does it mean for me? So all states will know how to cooperate in that regime which is not binding. So it's, example with confidence loading measures in several states. Well, it's binding, not everybody expects what they can get information for sure.
But in our case, though, I don't think this is not really a, I think we're making too much of this. Because this is one of those things where everyone always a big exposure to that. The tendency, I think, is going to be the other way. You go, hey, this is the right thing to do.
If you use like the space race, if you use the space race as a template, that was something that really the only advantage to getting to the moon or getting into space was effectively bragging rights, or to some extent being able to put stuff into space. In this case, it's the same, except they get bragging rights, plus they also potentially get to avoid a major negative effect. So I would think you would have the opposite problem. You would have various spacefaring countries saying, no, I want to be the one to deploy.
And there are major system-wide things that will happen in time after that. That's not what we're talking about, and also economic effects.
I think the economic effects are
If something
far less.
wipes Tokyo, the entire world economy could well go into depression.
Or if you have a tsunami and a major trading route that disrupts the other
Like the Fukushima Earth Day was. I heard that hundreds of miles north of here, dropped the world GDP by like 0.5% for like a tsunami. Which, I mean, and that was an unpopulated area, hundreds of miles from a it turned out to be where a lot of it was a home car, so you couldn't buy a red car anywhere in the world. Because the red paint came from that area.
And the tsunami over, what was it, specified tsunami, jacked the price of RAM, I mean, tripled it.
Yeah, we were Thailand,
And screwed up the whole deployment of the iPhone.
A related question would be of are there any nuclear power plants that are in the corridor?
There must be in an area that size.
Sure. So like you might have a secondary explosion that irradiates some
Although, we don't really care if you wipe out an area that's above the size of the radioactive. Well, that figures out.
Sure, but the radio, if it gets stuck into the atmosphere, it goes
Think of the scale of the 100-kilometer thing. It's probably blown by 10 orders of magnitude.
People in California are worried about radioactivity.
Yeah, but it's so you think about it.
Well, I guess I'm just not sure. No. If you spread like a small amount of radiation over the entire globe, isn't that any
Zawsze bardziej shell, the polarity is then you can discontinue take away the electron material. So you have to go to
By the way, I don't know if you remember, we met over the summer. That was part of the Frontier Development Lab.
Yeah. And I was looking at your paper over there.
Oh, okay.
Poster.
Yeah. Yeah.
notes the whole time, so we don't have to. Thank you. We're gonna have to turn to see the view graph.
Okay. This is the mic you guys can use to answer questions.
Thank you. Oh, we didn't take any down. Okay. Okay. So as questions come up, then grab the mic from me and ask them. Thank you.
So which one did we don't have questions for?
So we have, who do you consider, well, that's the question to answer. What areas are you using to evacuate? So we had several for disaster plans.
Yeah.
Okay. We talked about nuclear plants, some of those sorts of things. The planning group, we said, how much does it cost? What is the missions available? What is the most important?
For the threat discovery and characterization, we said about like if there's any mission currently that could be used to observe.
Could, yeah, sure. I put that under planning.
Okay. But,
Okay.
Yeah. Yeah.
So is group 1 here now?
That's a good point.
I'm sorry? Mark?
Nicola, can you shout at them if they start talking about magnitudes and orbital dynamics, something, anything you don't understand? Because
Okay, let me just... Let's go ahead and get started if we could.
we're sort of representative
And again, you know, this is
non-scientists,
exciting like a real
you have the
exercise would
relevant
be, so that's great.
So-
And as you can know, this one has a finite end time. Either it's going to be the asteroid impact sometime, or we've got people putting drinks and stuff out here at for our 6 o'clock adjournment. So I want you to stay on schedule with this. So the plan is going to be for...
Yeah, you're not.
is for the spokesperson for each group to come in and give a very short summary of what they discussed, and also, I think, be prepared to ask a question or two. And our heroic leadership group here has developed some definite opinions about things, and I think you may hear about some of that. So let me invite group 1's person, and we'll just kind of go down the list here. So go ahead.
We weren't sure if the speaker has to be me or somebody else, so we elected him, but... That's good.
By a vote of 1-0, I got elected, and I was not the vote. Okay, so the observers, I'll try to be in character here. So the observers held a workshop about 2017 PDC. We have all of the data to this point. Some of it's still being analyzed, so we need to hear what the results really are. But at this point, we have a taxonomic type. We have a light curve, so we have a pretty decent idea of what the composition is, we think, just based on a combination of the regular observing programs that are already in place, and then getting some director's discretionary time on some telescopes, because this is an important object. We have people going through the WISE catalog and looking to see if this is going to be observable by WISE. We think that it's above the sensitivity limits of WISE, so that once that analysis is done, we think that we'll have a... Oh, wow. Once that analysis is done, we think that we'll have a much better constraint on the diameter, even prior to a spacecraft. We definitely recommend that HST be used the next time that option is available in 2018. We also note that the JWST James Webb Telescope launches in October 2018, according to current plan, and that the mirrors are deployed and instruments should be powered on a little over a month later. And in January 2019, January 2019, it moves within the solar elongation bounds, so it should be observable by JWST. It is also moving at a slow enough rate that it should be observable by JWST, so that would give a lot better data. And then finally, we were going to check with the Gaia operations to see if they could support. We think they might be able to support.
Okay, Dr. Rivkin, I'm sorry, excuse me.
Yes.
We've just got our chime.
Oh, yep. Go ahead.
So we have some questions for you. Thank you very much for your presentation. It sounds like you've done a tremendous amount of work. I will lead off with, could you explain to us what you mean by a tax type, and what do you think this thing is made of?
Oh, absolutely. So we divide up different compositions, the light reflected off of asteroids and that is returned to Earth gives a measure of what they are made of. We then divide those different reflectance spectra, we call them, into different groups. So these different groups are given letters just to denote them. So there's a stony type, which is very common in the near-Earth object population. I don't know if that's what this is or not, but the analysis is ongoing, and I'm sure we'll hear from whomever is responsible.
So bottom line, is this made of aluminum, steel, rock, linoleum? What do we got?
At this point, before we hear from...
We'll know. We'll know later. Okay.
We will know later.
From my esteemed colleagues in the World Space Treaty Organization, do we have any questions? We'll take questions from...
When are you going to know if this hits for sure?
That's not our purview, I don't think. Is that our purview? Is that up to us? Oh, I guess it is. That analysis is underway. We don't know yet.
So what is the exact date of the first time we'll have really images, and whatever you plan to get those information, if it fails, do you have a second plan?
Images of?
Or any information, the first exact information you're gonna get. When are we going to get them? And from the plan that you have to get them, if it fails, do you have a second plan?
I'm afraid that is a vague question compared to what we're used to. We have images of it on the sky, so we already do have some data. If you're talking about
I don't know
images
anything, I'm
of
a
it,
politician.
Yeah, I understand. If you're well, as a politician, if you'd like to fund planetary science at a higher rate, I'm sure we can get you more of what you're looking for. But the first images of it showing rocks and craters and stuff, that would depend on if you choose to send a spacecraft there. Okay. But right now, we could only see it just as a star-like object moving across the sky, which is where the term asteroid comes from, actually, star-like.
So the bottom line is we know what we know for now. We may know more in a couple of years unless we send a mission to go look at it in person or in close-up?
There's a limited amount of data that we will be able to collect from the ground. And there's a larger amount of data we'll be able to get from space-based assets like JWST. And that is only going to get us so far. It might be that data is enough to rule out an impact. It probably will be some time before we could rule in an impact for some, at a higher probability level. And then some of the information we are only going to get from visiting the object with a spacecraft.
Okay. Any further questions?
I think you had.
Yes.
Are there any other missions that could be diverted other than JWST and HST?
We looked into a bunch of space-based assets. We looked into whether any of the spacecraft at Mars could look like they looked at Comet Siding Spring a few years ago, you may remember. We looked at whether OSIRIS-REx or Hayabusa 2, if it happened to go through their fields of, if it was bright enough for them, it's not. We looked at the stereo spacecraft, which are solar spacecraft. It is not. The Spitzer Space Telescope is not particularly close to the Earth, and so it might have appeared brighter from there. It is not. We
we think we did our due diligence, but
So, in the past, I remember reading an article where a spacecraft that went to look at a comet got finished its mission and then went to look at a different comet. Is there anything in the neighborhood that could be turned away from its mission the way we might divert a carrier group?
well, we could just say we're going to do it, I guess, and then.
Could you look into that for us, please? Okay, next group, please. Thanks, Bill.
All right, we are the Impact Effects group, and basically we have a very wide range of possibilities for the sizes and given what we do and do not know. Could be anything from a worst case scenario of 29 million people being affected to no one being affected if it lands in the ocean and it's on the smaller size and less dense size. There's about a 10% chance of more than 1 million people being affected. And pretty much what it comes down to is we need more information in order to give you better analysis and better support. We need to know location, location, location most of all, because ocean, 0 for the lighter sizes, and even at the smaller sizes, if it comes down over Tokyo Metro, you're in trouble. So we need to know location and also size and mass would be very helpful to help us refine our analysis to tell you better.
Okay, and quick question, that 10% number, that is if it does impact?
Yes, that's if it
Okay.
impacts, there's a 10% chance that it will affect more than 10 million people.
Okay, thank you.
More than
President
1
Morrison?
million people, sorry.
That's exactly,
President Chapman,
that
sorry.
was my question.
That was your question. I'm so sorry, sir.
Yeah, basically, sort of simple question. Whenever you have to make a decision on something, you ask, when do I need to make a decision by? Or in other words, and are you going to get any more data between now and then? Am I going to learn any more between now and then?
And that depends what the characterization team can give us and what missions you all decide to send out in order to get us more data.
I mean, so you're saying it's possible to get the answers to these questions?
Yeah, depending on what missions go out, but the, how soon those need to go out is really more the mission teams. We can tell you what happens if it impacts, but.
So I guess if I was a decision maker, I would ask two questions. Your best guess and worst case.
The worst case is 29 million people.
Okay, and not in terms of people, put it in terms of the size of a weapon that I understand. Because I don't know where it's going to hit, right? So it completely depends upon where it's going to hit. So take that apart and just.
What was that, Mike?
So when you do your assessment, your models, do you consider whether or not this would hit on a nuclear power plant? You know, what it actually will hit?
We do not have infrastructure in our current analysis. We do it by mostly the blast damage zones and also tsunami if it hits in the water. So it's taking a percentage of people in the different overpressure zones and counting those as affected population. They're not necessarily casualties. It could be a representation of damage. It could be a representation of how many people are injured. So it's a fraction of a population within a damage area.
That would be bad, right? If it hit a nuclear facility, don't you think you ought to have that in your models?
That would definitely be a good capability to develop, yes.
That was my question.
Do your models take into account large-scale economic effects? Like if say it lands in the ocean and it doesn't actually create a tsunami that reaches land, but it destroys an entire shipping fleet or something. Is that taken into account?
No.
Okay.
I heard 1.2 gigatons, correct? What does that compare to, say, our entire, the nuclear arsenal of the world? What does that compare?
I don't have that as numbers for you.
I mean, are we talking?
50 megatons is the largest
Okay.
thermonuclear device ever.
Okay, so this is bigger than everything we've got.
All the nukes in the world.
Okay, so this is all-out nuclear war in terms of the size of the explosion. correct? I thought you said, oh yeah, no, in terms of the size of the explosion. I'm just trying to get him to explain the size. Okay, and you're telling me that a nuclear weapon is how big compared to this?
The total arsenal of the world is a quarter, tens of thousands of nuclear weapons yields from kilotons tactical to megatons strategic. So you add up all the weapons in the world, they're a quarter gigatons.
Okay. So, but it's maybe 1/10 of that.
It's about half of all operational bombs.
Okay, so it's close to all the operational bombs. Is that what I'm hearing? I mean, I'm just trying to ask this like a leader trying to put this into perspective.
Yeah, I have a simple question, which is, are you, any reason you cannot immediately launch a study effort to map the infrastructure and to do all these studies starting tomorrow?
Again, that would be a question for the Decision to Act team and the
Well, I mean, you as an expert on impact effects, I mean, what does it take in the way of funding or in manpower or?
we specialize in what happens if it hits. I'm sorry, I don't have that information.
Thank you for this information. All right, I'm representing the deflection group, and we talked a lot about the range of possible risks associated with this current threat, and given that it's currently at a low probability of impact, and that the size is not well constrained, our recommended actions are really going to depend on what we can learn from a rendezvous or flyby mission. So there's a strong preference for a rendezvous mission if possible, and the next speaker will speak to that, but our recommendation will really depend on that. The things that we're looking for are to constrain, first of all, the mass of the asteroid, its orbit, to know specifically which region of the Earth it will threaten if it does impact. That might affect our decision to how and if to deflect it. And also its rotation rate. If it's small and it's rotating very fast, for instance, it will be difficult to keep it intact. Subsurface structure, if possible. That's nice to know if you're going to intentionally disrupt it. So given that, that's our first recommendation. The second would be to begin building immediately possibly a slow push method and enhanced gravity tractor, which could go, and if it is a smallish asteroid below 140 meters, we decided that could be handled by an enhanced gravity tractor. So it would not do any harm to build that and send it anyway. As a carry-on, if it happens to be a larger object, we could also send a nuclear device and not use it if it's not needed, but use it if it is needed after that rendezvous is associated with that rendezvous mission, the gravity tractor rendezvous. And lastly, pending the results of the rendezvous or flyby mission, and pending the size of the asteroid, we know on the very large end of the spectrum, if it's 300 meters across, it's going to be very difficult to deflect with kinetic impactors, even a fleet of them. And so we would probably need to use a standoff nuclear device to deflect it. But if it's somewhere in between and we think we can deflect it with a fleet of kinetic impactors without accidentally disrupting it, we would prepare to launch a fleet of smaller masses that all gently nudge it in a way that we don't worry about accidentally disrupting it. Okay, thank you very much. We have a bunch of questions here, so we'll start handing around.
You mentioned that one possibility was to send a nuke out there and then not necessarily use it if we don't need to. Who would be in charge of owning that nuke that's now floating around in space? And how do we make sure that it's not used improperly in the future?
Well, it would need to be one of the spacefaring nations and one of the nations that has a nuclear program. So it's the most likely candidate would be the United States. I suppose you could have it under also jointly controlled by the coalition of countries that are working together on the problem, depending on what politicians decide. So that's kind of outside of our jurisdiction, really. But
I'll take chair's prerogative real quick before I hand it to President Chapman. What is, for the various methods that you have prepared for us, what's the lead time? And if you don't have those, could you prepare them for us?
So the lead, I don't have off the top of my head the lead time, but it's going to be more than a year for each of these. The technology is readily available. It's just getting the spacecraft built. And we did talk about repurposing previously used missions so that there's no design really going into it. You're just rebuilding something that's already flown, like an OSIRIS-REx or something that's already gone to a small body.
Okay, could you then put us together a chart telling us what the lead times are, given the time we have available to us? For the
Sure.
various options?
Brent might be a better person to do that,
Okay.
but we'll talk with them.
Okay, yeah,
I
if you
guess.
could work with him with that, I'd appreciate it. President Chapman.
Are you sure that at 1% probability of impact, which we're at right now, that you really want to begin all these development exercises for deflection and so on at 1%?
I think given the very high consequences of a 300-meter asteroid impact in a populated area, and it's relatively cheap to build these spacecraft, if we're taking something off the shelf, I think it's worthwhile to get something there right away to observe it more carefully, and also to begin preparations for an enhanced gravity tractor with the option. It doesn't have to be decided right away, but the option to bring a more energetic method.
Okay, thank you very much for your input. Sorry, we're out of time.
Okay, campaign design. So,
Please speak into the mic.
so our recommendations are that during the year one, we have at least half a dozen Phase A studies. So we have to decide whether we're sending something cheap, flyby mission, so like a tech demo, or we are going for a slow, more detailed reconnaissance mission. We also have to immediately start deciding whether we are going with kinetic impactor or nukes, and this is going to also put the teams in place. But we can't wait really for the Phase A studies to complete. We really, our recommendation is to start with a flyby, with a really quick flyby mission that is going to have a kind of zero order action and is going to prepare. The objective of this fast flyby is going to be whether impact probability is 0 or 100, what is the diameter, and what is the shape, because we know now that this asteroid has, we have a one-third probability, one-third that it is either binary or contact binary, and this is going to be important for mitigation teams and for the teams, on the ground to prepare. We need to have policies in place for nuclear option. So this is something that has to be in place before something like this occurs. We need to be able to support deflection mission in 22 to 23. We need to start tracking all the spares from missions out there, because they end up kind of being lost. So these pre-done off-shell components, we need to know communication equipment status that can be just taken off the shell, high-quality imaging tracker, and spectrometer. And finally, we need to look for option for launch vehicle. So this
Okay,
is first years.
I'm sorry, excuse me. That's most of that's going to be stuff that we need you to tell us. Can you give us a bottom line for, again, I'll ask the question, can you divert anything that's already up there, or how fast and how expensive to get your various options that you need?
So we know that we need to launch, we need to support the impactor by 22 or 23. So by then, we are going to do all these prerequisites, and that means fast flyby and possibly reconnaissance.
Okay. When would we need to start preparation for your fast flyby and for your reconnaissance?
Day one.
Day one? Okay.
Yes.
When is the latest time we could launch them?
So the fast flyby, that would be really like tech demo mission. We'd probably be able to launch within the first 2 years.
First 2 years is the soonest. What's the latest that we could have any useful information from it?
For the latest, yeah, we could wait longer for the reconnaissance, so that would be 3 to 4 years.
3 to 4 years after
Yes.
day one.
So the odds are there will be 2 missions. There would be first one would be flyby, and the second one would be reconnaissance.
Okay, thank you. I'm sorry, please excuse the interruption. Can I open it to questions now from the rest of the body?
The question would be, how many kinetic impactors we might need to simply equalize the nuclear solution? Because, it would be much more easier for us to cooperate, if we are using a fleet of kinetic impactors instead of one nuclear solution. And the second reason would be that if we miss with the nuclear solution, then, it's one miss and we are gone. So the fleet would be a more wise approach.
Well, those are going to be the results of the Phase A studies. So once when they are completed, you're going to have better understanding whether you go with a nuclear option or you go with a kinetic impactor and how many are required. You can't figure out how many kinetic impactors are required before you don't know anything about the asteroid. So all that, you really can't make a decision before you see at least the results of the fast flyby.
But why wouldn't we wait? It's only 1%, and Dr. Rivkin just told us we'll get some really good observations in another year or two from HST and JWST, and we should wait maybe.
Yeah, because initially you're doing Phase A studies and you're preparing your teams. So you're going to have your teams in place for the worst case scenario. And at the same time, launching something that is a flyby mission and by using off-the-shelf components or spares is something that is not going to be excessively expensive and can be done quickly. So, so that is it doesn't bring too much risk.
Yeah.
Okay.
Thank you very much.
Yeah, okay. So we looked what recommendations we could give on whether one should act or not. So we understand there is only a 1% chance of the object to hit in about 10 years' time. And this we have had before. So like in Apophis, and a few days later, the chance went from 4% down to not zero, but a very, very small level. So we think at the 1% level at present, it is not justified to really recommend already building or asking money to launch any mission for this object. 1% is simply, it's unrealistic, the level is too low. But one should not completely ignore it. We understand the potential huge consequences. It's also understood that there are basically only this year opportunities to get additional observations. So to bring it down to zero, the impact probability, that's what can be expected, or to bring it up to a maximum of 26%, if we understood it correctly, at the end of this year. So our first recommendation is not to start real preparation for any mission, but second, to request with highest priority all additional possible observations that are possible, and to do them as quickly as possible. And it should include asking for some political support to get high priority. This includes using the HST, maybe through USA or through member states, through space agency. One should use all means to use what is available. It should not be a problem to get it from the ground. Of course, most important is the impact probability, because otherwise, at the end of the year, we would have no new information. We would stay with this 1% if there are no new observations. It should also include getting additional information on the size of the object. We understand radar observations are not possible, but for example, you could get some size by thermal infrared observation, so there are some facilities. So the recommendation in the positive sense is use whatever you can as soon as possible to get additional information. And also, it is realized, so we have a 1% chance of an object which is reasonably big, and one should follow the recommendations of I1 and same page. So you inform the authorities, USA, civil protection agencies, because it's an object exceeding a 1% chance, larger than 10 meter for I1 action, and also larger than 50 meter for same page action. But at this level, 1%, the recommendation is you should start mission option planning. That means you look at the reference missions we have already, what could be done, what type of deflector would be available, what hardware tools do we have already, or what should we need to develop. And that is one aspect, to look for a potential deflection mission, but also, and maybe with high priority, one should also look at a reconnaissance mission, so a smaller one, flyby or rendezvous, so one should plan these at the same time already now, because that is something that does not really cost money, but it's foreseen to do this, to be prepared as soon as possible to act if the probability should not drop to zero, what we all hope will happen.
Thank you very much. Let me pass this to President Chapman here.
So you are definitely not recommending commencing even a very inexpensive flyby mission?
I would recommend to start the planning and to look what is possible, but not to start asking for money to do something. Because I think if it goes up to 10%, we might consider this again. But first you should start the initial planning, but we would not recommend start building already a mission.
Does that mean to begin the Phase A studies recommended by the previous speaker?
I'm not sure whether I would go that far. Of course, if someone wants to do it, he could. So I would just suggest to look what information we do have already right now. Start mission option planning. A Phase A study is already getting into more design. It's already one next step, I would say. It costs already more money.
So that's farther than you would recommend?
I would say that is further than what we would recommend at this stage. But again, I said one should start the first preparations and to get ready as quickly as possible. We understand there could be new information by July.
Thank you for your guidance.
We would wait for that.
I'm sorry, our constituencies will be reluctant to miss the party this evening. So thank you very much. Yes, sir.
Could I ask at what level of impact probability you would recommend commencing?
We have not gone that far in our group of decision. So if it doesn't drop to zero, we will have to discuss that at the next round.
Okay. Okay. Thank you. Thank you very much.
Hello, I'm Bruce Betts. I'm representing the communications group, and I want to take for 10 seconds to step outside the exercise to tell you our group's assumption was that the presentation we saw earlier today this afternoon was not yet public, and that we were advising leaders on how to present the information that they know. All right, back to the exercise. So our recommendation is to put the basic information out there early and be upfront about it. A lot of it's going to be online anyway. As possible, there should be consistent messaging between different actors, different member states, perhaps coordinated or at least with basic information sent out by IWAN. We recommend that you do not show the detailed impact analyses at this time, the bullseyes, the death and destruction effects, not when you're this soon after discovery and only at a 1% probability. That can be reconsidered at a later time. Stress that we're still, which people have been, stress that we're still doing observations, that based on our experience, the probability will likely drop, and then be explicit about what the observation opportunities are, what times, what telescopes, what are the opportunities that we're getting these observations. Finally, then we need public access information in general to explain the terminology and jargon, and then pushing out trusted sources, international sources, IWAN, UN, etc. Thank you.
Thank you very much. That's quite useful. Do we have any questions?
Well, you know, we don't want any of that fake news. to be put out there.
We do not advocate
Yeah.
fake
So,
news.
so what would you tell the public specifically that they could understand as to, you know, what would happen and not be afraid?
That this is typically, although the 1% impact probability is what we understand at this point of how, but when we get more observations, then we understand the orbit better. And usually when we get more observations, that probability goes down, often to 0. So this is something to pay attention to, that the world's taking it seriously, that there are more observations planned, but that it's not something to lose sleep over, at least not yet.
How much of this information is already in the public domain? How much could be kept close hold at this time, and how much is already known or could be quickly put together online by an intelligent amateur or a vociferous expert?
Well, I think that's why it's important to get the information out there to try to explain it, because a lot of this information is online. The observations are public, the orbital calculations are public, and that's going to be out there, can be found very quickly. So I think the key is to get behind that information ourselves so that one can explain things like impact probability and more observations coming up sooner rather than later.
Okay, thank you very much.
Thank you.
Thank you very much for that. Ma'am?
Hi, thank you. I'm Barbara Jennings. I'll be talking to you about our recommendations for disaster planning and management. And at this stage, we think that we came up with 3 points that we think are important for you to consider. The primary, number one important point is to educate the people that are going to be potentially impacted, the agencies that are responsible for delivering emergency response, and then allowing the governments to come together and determine how to respond best. We have a very wide swath of area here, so we don't feel that it's our role to go to the population and speak to them at this point. There's only 1% chance, and it's out for 10 years, so we don't want to get people unnecessarily disturbed. So we feel that the best thing to do is take it to the disaster agencies and let them work with their individual cultural groups to determine how best to present the information. Okay.
Thank you very
questions?
much. The bullet points are very useful. Questions from the floor?
What areas of these would be easiest to evacuate?
Say it again, please, sorry.
Which of the areas, the major cities that are impacted, would be easiest or hardest for us to impact or evacuate?
To evacuate? Wow, that's a question. We didn't really go into that detail at this point, but when we do a little bit more research, you find out that a lot of these cities do have plans in place already to handle the evacuation. So we have not, I don't have that information at hand for all the cities, but some of them we know that Japan, for example, does have drills in place for handling evacuation, but that's definitely a good question to ask, and we'll look for that answer.
Would you recommend at this time that at the local level, perhaps the mayoral level or the state level, province level, that those authorities begin brushing up on their evacuation drills, or is this too soon? Is this something where policy needs to be reviewed?
You know, at this stage of the game, we are going to let the responders make that decision. They're the experts. They know their culture. They know how people are going to react. They know what their capabilities are to evacuate. There may be some individuals who evacuate, some that have shelter in place. And it's just too early to tell exactly how people are going to be impacted, and we want to be really cautious not to overreact.
Thank you very much.
Okay.
Given that drinks are waiting, you guys are going to need to decide what to do here. But before you do that, I'd like to have Paul tell you some of the timing issues and the fact that you, based on what you do and don't decide, what your decision will be next time.
In a way, I represent Mother Nature. Mother Nature will make some decisions for you. You need to consider your decisions need to cover the next 2 years. So please consider that when you make recommendations, because tomorrow night it'll be at least 2 years in the future. And there are consequences of inaction.
Thank you very much. So, Bill, are we allowed to have a breakout session while everyone steps away, or do you need us to be on camera to provide our recommendations?
To have you kind of discuss it among yourselves while people are here, so they can sit here where the points are and come up with some decisions. Does that work for you guys? Or do you want to take 5 minutes aside and we're going to go?
Might as well discuss it.
Well, our constituency has requested a transparent process, so apparently we have a transparent process. Okay, so Bill, what kind of timeline do we have for making this decision then?
Well, basically, as Paul said, you need to make some basic decisions tonight, and that is,
Mhm.
number one, what do you want to do about setting an observation mission?
Yep.
Do you want to get that started now? Do you want to start planning for that? Do you want to sit and wait and do nothing? The probability goes up or goes down?
So simulation time is 2 years, but in terms of people sitting here with the drinks being out there, how long do we have? 5 minutes, 10? What's our timer set for? We're politicians, we can talk. Oh, can you give us half an hour? Uh, 10 minutes? Okay, 10 minutes it is. I'm going to stand up so I can see everybody because I've got my back to half the team here. Okay, we have a lot of people who want to speak, so let's go quickly round robin, and I will ask you to pass the mic to the next person when we're getting short of time. President Chapman.
It's my perspective that, of course, everything ought to be studied. I mean, that's cheap, and this is interesting enough that it's a good case to study on all of these topics. But it seems to me that if possible, steps should be taken towards launching an inexpensive a mission to investigate the asteroid, just because, heck, it would have scientific return if nothing else. And so why not? The next space mission might as well start as soon as someone's interested.
Thank you. Next.
I would like to say, I think my two colleagues on my right, at least from what I heard and myself, were quite disturbed that we had different versions between a decision to act and campaign design. So I got convinced that we should do a flyby, but it was quite, I mean, it put me unease to hear that by the decision to act group, that actually we don't have to do anything. So, so I would suggest that between the groups there is coordination on what you're going to tell the politicians, because otherwise we would be pushed not to do anything or to fire people. And lastly, I would say that for the disaster planning, I more have a question than a decision that I wanted to ask the group. So hopefully maybe in the next 2 years it could be done or put into place to have maybe first planning of international organization to evacuate people, because I understand that right now we don't need to bring those problems nationally, but are there any international coordination possible?
Okay, let's table that for the response group, please. Next.
Especially given the indecision between the decision to act group and the campaign design group, I don't think I would really feel comfortable telling my constituents that I'm going to be using their tax dollars, wasting their tax dollars on this thing that basically can't happen, right? It's 1%. So I think I'm recommending not to do anything.
Inaction. Okay, thank you. Next.
Yeah, if this whole exercise pointed out to me how important it is getting the story straight before it's presented to leaders, and I realize this is artificial because the groups are reporting separately and they didn't coordinate and so on, but should a real incident happen, obviously there has to be huge cooperation with everybody to get their story straight, because you can't have one group saying one thing and another saying another thing. I think I would have kept it simple if I was a national leader. I would say, you know, what do I need to do now? What information is going to get better, and when do I need to really, what is my escalation thing if this gets worse?
Okay.
And those weren't clearly stated to me. And I think, really just very, very simple things is what's important.
Thank you. Next.
I would say divide it into, say, two branches of the decision. When it comes to the decision related to the observation, I think it's not going to cause any international trouble or given the fact that we live in an international system of nation states. So let's launch the observation missions because it's going to give us more information. But the second branch would be the deflection mission, and in that perspective, I would be happy if we can stick to the technology which is not going to cause any international troubles or international security concerns. So if there is a possibility to send fleets of kinetic impactors, so let's build as many as possible. Then just let's start thinking about how much does it cost to build a fleet of kinetic impactors and make the decision.
So we'll task mission planning to start getting us some prices, please. And next, please.
I think there's some things that are missing. I would like to get a global security briefing. Some of the impact areas are near parts of the world that are very unstable, like North Korea. And so I would like to get a global security briefing. I also heard that there are some lacking capabilities in our modeling, like for example, that we need to quickly try to upgrade, like for the effects to include the infrastructure piece. That sounds like an investment that would be quite worthwhile.
Okay, thank you. It sounds like effects needs to look at infrastructure that might be affected, chemical plants, biological issues, oil fields, things like that, shipping, transit lines, all of the above. For global security, let's hand that to disaster planning and management and communication, please. Look at the international effects and any possible implications for economic and political issues. And then next, please. From the head of the United Nations.
Yes, I have a concern about the communication because the people, depending on where they are on the globe, they will not be concerned at the same level. So there will be a requirement of communication of the people, the countries in the corridor itself, and certainly much less anxiety in the part of the world. In this neo-planetary defense area, and in many other areas, the communication comes from NASA. The US are not concerned by this, by the impact, so I think there's a need for, even if the US is not concerned, to keep strong involvement with respect to this communication problem from NASA with the other communication agencies from the most concerned countries.
Okay.
So it has to be thought from the beginning.
Okay, we're getting short of time, thank you. And then could you pass the mic back to the scribe, please? Hold that for a second. So let's task communications with giving us a list of experts who have some skin in the game, who come from countries that are within the impact ellipse. Okay, then do we have, from our scribe, do we have any very pressing questions? And I will give you just 30 seconds to tell us. Sorry, no pressure, dude. But that's how the daily briefs go for many leaders, for questions that we wanted to ask.
No, I don't think we missed any of our major questions. There was some more
Okay, thank
detail
you.
in areas, but I think we're relatively good.
Thank you. Then we have decisions to make. And so we have at least 2 votes for use available assets to study. So would you gentlemen like to put a motion on the floor together or the 3 of you, to watch and wait? Would you put forward a motion so we can vote on it, yes or no?
So I can just give you when they went around, we had 3 people for launching an observation mission.
Okay.
And 2 people that were against it. The others didn't comment.
Okay.
So we can get the other votes, or we can go with that.
Let's get the other votes then, please. All right. All in favor of watch and wait? Hands? 3? Okay. All in favor of, or all against watch and wait? Is everyone else so okay?
Flyby mission.
Flyby mission? Okay, flyby mission. Okay, it is resolved that we will prepare and fund a flyby mission.
Who will fund
All right, President Chapman, I notice you have a capacious space agency in your country. Might I propose that, as a show of goodwill, you might put forward with your space agency a rendezvous mission?
You don't know that I represent Paraguay. I would think that the United States or...
I'm sorry, could somebody give Clark the microphone? Thanks.
I would think that the United States or Europe or Japan, particularly if they're already working on a future mission that could be aimed at this target, I think the funding isn't that much of a problem.
Okay, so there may be an expectation there for demonstrations of goodwill or commitment of resources as an altruistic gesture. Okay, I'm going to ask a rhetorical question because we are very short of time and I don't want to be voted out of office. If we had something that was getting prepared for launch or was ready to go and might be diverted, but in ways that might derail scientific careers or political constituencies, important assets, something, say, like if a Hayabusa 2 were not yet launched, or something equivalent, were not yet launched but was ready to be launched and then was told to redirect towards this object, what would the fallout be? And I'm going to pose that as a rhetorical question to be discussed in the post session. So do we have any further questions from our threat masters? Anything else you need to know from us? Okay,
Is there anything else I need to answer right now?
Good question. We didn't get into the mission timelines of some of the missions, but a rendezvous mission I heard was voted, as opposed to a fast flyby mission. The fast flyby mission would get there earlier.
A flyby mission was voted. A rendezvous was a flyby mission was voted by the treaty organization, and the rendezvous was proposed to a country with a substantial space agency as a hypothetical altruistic gesture.
Then it shall be. Now, one other question. I didn't hear a recommendation on the HST observation.
Yes, that was resolved.
Then it shall be.
All available existent assets were
Okay,
part of
thank
the
you.
watch and wait.
Okay, well, I think I just want to, one quick one, yes?
Yes. Who are they and who are we?
You are,
For instance, in the decision to act, are we supposed to be thinking that we're decision makers or they are? Or what?
you are the people recommending what these decision makers are going to do. So again, that's the issue. So they will, if there's a decision to act and you're one of those people who does acting, then you would be authorized to go forward and have the funding to do it. That's how it would relate, just like it is in the real world. I mean, more or less. So, okay, again, I just want to thank our exercise groups. You guys did a great job, and I want to thank our leadership group. I think these guys are going to be. I assume that you're going to stay with us for the rest of this exercise. So we'll see how your decisions play out. So that's great. And again, I thank all of you for participating in this. And go get something to drink.
Thank you.